Hi everyone. I always wanted to create this kind of effect with running lines, but I didn't know how to do it before. Now I finally know, and since it's a relatively simple algorithm, this video won't be extremely long either. Let's start with the tutorial. So, as usual, I'll start with a new scene in Godot 4. I say Godot 4 because it's the game engine I work with most often, but it shouldn't be difficult to use this effect in other engines as well. I'll name the scene Quicks because that's the name of the game that made this effect famous in the last century. Okay, so right click on the scenes, create new scene, let's call it Quicks, and okay. And as usual, I'll add a color rect as the child node. Color rect, where is it here? And set its parameters. So we usually work with this layout. It should be 600 by 400. And a new shader material. New shader material, click, and new shader, which we can call Quicks 2D shader. Of course, it's canvas item type. I'll just put it to the shaders folder and create, and click to open it in the editor. Okay, and I'll delete everything we don't need, so only the fragment function remains in the code. Vertex and light. Great. For this effect, we will need to draw lines, which isn't as straightforward in shaders as it might seem in other languages, where we simply call a function like drawLine or similar and don't worry about the rest. In a shader, we don't have anything like that, and we have to write our own drawLine function. This function will have three input parameters, the UV coordinates of the current pixel and vectors A and B, which represent the start and end points of the line we want to draw. For now, the function always returns 0, and shortly we will implement it to return the pixel color. So as I said, I'll define float, as it's supposed to return color of the pixel, draw line with the parameters I just mentioned, so UV coordinates of the current pixel, and vector A and vector 2B. Very well. And return 0 for the time being. So, why are we doing it this way? A shader differs from a regular program that its fragment function is called for each pixel individually, and these calls occur in parallel, meaning all pixels at the same time. Therefore, instead of drawing a line from point A to point B, we need to calculate which pixel belongs to the line and which does not. There is a well-known algorithm for this calculation, which I won't explain in detail from a mathematical perspective here. I'll simply write it and briefly describe it. But first, however, we will need a parameter to define the thickness of our line. We'll add it as a uniform parameter right here. Uniform float line thickness with a hint range from, let's say, 0.01 to 1, and the step 0.01 as well. Default value could be 0.1. Very well. And now the function itself essentially will perform the following operations. We'll calculate the distance of the current pixel from the expected line, project this segment, trim the resulting line using the endpoints, and set the thickness using the smooth step function. Let's do it. So draw line is here. Now we need to do this. Vector 2, call it BA, is simply a difference of UV vector and A vector. Now vector 2 BA would be the difference between B and A points. Now we need to do the projection as I mentioned. Let's call it H for instance, and we need to clamp the result just to trim the line so it doesn't go indefinitely but would be from point A to point B, and the projection itself is a dot product of PA and BA divided by dot product BA and BA. As we are projecting the line from our point to the expected line and to the line itself, and clamping from 0 to 1. Very well. And finally we need to return the line which is where we apply the thickness using the smooth step function. Smooth step, and we already defined the line thickness right here, so let's use it, and we will make it with these boundaries. First is multiplied by point A, the second one multiplied by 1.2, so it's just above and below the original thickness value, and what we are applying it to is the length of PA minus BA multiplied by H. Okay, that should be it. And now we need to call this function from the fragment function. To make the effect easier to create, we'll start by shifting the origin of the coordinates to the center, because we'll be working with trigonometric functions whose values fall within the interval from -1 to 1, so it's beneficial to have 0 in the middle. Once we have that, we'll draw a simple line between 2 points. Let's do it. So as I said first, shifting the coordinates, UV is UV minus 0.5, and now we will create the color of the resulting pixel vector 3, because we are not using alpha channel in this algorithm, and we start as 0, which is the black color. And now we need to add the result of the function draw line, which takes these parameters UV, and now the points. Let's make a line from the center to something over there. So the first point would be vector 2 with coordinates 0, 0, and the second one, let's make it vector 2 with coordinates 0.2 and 0.2. And finally we need to display the result, so we assign it to the internal color variable, which is vector 4. So let's add the alpha value of 1 and wait for it. And yes, the line appeared exactly as we expected. We can try changing the line thickness in the inspector. So let's make it just a thin line or thicker. Anything can be done with that. Okay. Alright, so that's one line. But we want more of them, and we also want them to move in the way I showed at the beginning of the video. That won't be difficult because the hardest part, drawing any line, we already have. Now we'll just define the movement trajectories and add a bunch of other parameters that will allow us to adjust the effect as needed. I'll add them all at once now and gradually explain how to use them. What I wanted was to scroll the code and add the parameters. So first, uniform float speed with a hint range from 0.1 to, for example, 20, and the step 0.1 and start at 5. This is basically the speed of the line animation. So the bigger the value, the faster the lines should be moving. Now, as we can see, the line is pretty big, and we definitely want to use complicated trajectories that could easily fall outside this region. So we need a zoom factor to zoom in and out. Uniform float zoom with hint range zoom should start from 1 to, let's make it 100 to give us some space to manipulate that, and start at 10. Very well. Now another very important parameter is the number of lines we want to display. Right now we have 1, but in the effect at the beginning of the video I think we had 100 lines, so let's make it here. Uniform, and this is integer as we don't need any fractions of lines. Line count with a hint range from 1 to 100, and 1 is the step, and let's start with 10 lines. Okay, so we already have the line thickness, and now we want to apply the zoom factor on the individual lines as well to fine-tune the resulting effect. Let's call it line zoom. Uniform float line zoom hint range from 0.1 to 10 and start with 2. Okay, and of course it wouldn't be nice to have the lines just in shades of gray, so what's the final color to apply to the resulting effect, which would be uniform vector 3 RGB color line color, and if we give it the hint source color, we will have a nice color picker in the inspector to select the color from, and it should start at, let's say, I had this nice red color at the beginning, so let's do it. Red is 1, green is 0, and blue is 0 as well, and we can already see it here. Perfect. And last two parameters would be step size, which will simply define the step and the space between individual lines, so it would be float step size with a hint range from 0.1 to 10 and 0.1 as a step, and let's start at 1. Very well, and the final, we want something called fade factor, because as you remember from the effect, the following lines were displayed in a color with lower brightness, just to create something like a fading trail. So that's exactly what this parameter would define. Fade factor with a hint range 0.1 to 1 and the step 0.01. Okay, and start at 0.75. Great. And now let's finish the fragment function. So first we want to apply the zoom factor, which means we will simply multiply the UV coordinates with it. Okay. And so as I said, if the lines are drawn outside our color rect, we can change the zoom factor to see the entire effect, and we can already see that the original line has been zoomed out, which is what we wanted. Alright, and now to set the desired speed of the line's movement, so that would be float, let's call it time, and the internal variable time multiplied by the speed parameter. Okay, and now we have to get rid of this line and replace it with a proper cycle. So I'll just do it here. And let's define the cycle for int e from 0 to our parameter line count, e++, and the cycle itself. Okay, so first, to create a trail of lines, we need to shift the parameter that we pass to the trajectory functions, and we'll shift it by the time factor, so I mean by the step size factor. So the time, which will be passed as the argument, would be increased by the step size. And now the fade factor. Color is multiplied by the fade factor. Because if we don't do that, all lines would have the same color intensity. Okay, and now to define the points A and B that define the boundaries of the lines. So first vector 2A is vector 2, and as I said, we'll use trigonometric functions. So start with sine time multiplied by 0.4. This is just to reduce the speed of the boundary point, so the line movement isn't too regular. And cosine time by 0.6. I will explain this shortly. And let's make the point B in the similar way, like 2B, and this time I'll start with the cosine time multiplied by 0.7 and sine time multiplied by let's try 0.3. Okay, so as I mentioned, we use trigonometric functions for the periodic behavior and the values in the range of -1 to 1. I simply tried these constants by trial and error. And of course, you can try changing them or turn them into additional uniform parameters. Or for instance, if you want a more regular movement, you can make all of them the same number. Very well, and finally, we need to get the value from the drawLine function. So as before, color is increased by the drawLine with parameters UV. And now point A multiplied by the line zoom. This is what I said just a while ago, that we need the individual zoom for the line, for the lines, and the same for point B by line zoom. Where is it? Here. And the result should be multiplied by the line color to make it red in our case. You might have noticed, yeah, it's already here. You might have noticed that we are adding the result of the drawLine, which is float, to the vector 3 color. It is simply a shortcut in the shading language. It means that we will add this float to all components of this vector 3, so to the red, green and blue color. That's why it results in a shade of gray, and now multiplied by our color, it's a shade of red. And finally, what? Yeah, I mean, if you feel that the trajectory is too erratic, which probably is not, but it's just everyone's opinion can be different. So we can add more trigonometric functions to smooth out the result. Perhaps like this. Let me just increase that. We will add another vector. This is completely optional. I'm just doing that because I had some nice results with it. Multiplied by 0.2 and this one 0.3. And similarly for the vector B. Okay, plus this vector multiplied by 0.2 and 0.2. Okay, yeah, this is nice, and I think I even changed the order, so it will be sine here and cosine here, but anything can be used there. I mean, the important thing is that the functions are periodic and their values are within the range from -1 to 1. So I would say we are done, and we have so many parameters available right here. So many parameters that we can play with their settings for a long time and explore the results we can achieve. Let's try, for example, increasing the fade factor to 1. So now all lines are of the same color. Reducing the line thickness and step size to the minimum. Where is line thickness? Here, minimum, and step size. And line count to maximum 100. This is pretty nice, isn't it? It's actually similar to the effect which I showed at the beginning of the video, but it's a little bit different. There are, I think, maybe more lines and smaller step between them and other things. And what about this? Let's just revert everything. So I will lower the speed to 0.8, for example. Line count should be increased to 100. Step size, where is it? Let's make it 10 this time. And fade factor, increase a little bit, so we can see more lines. This is a pretty interesting effect as well. As I said, you can play with them and create a lot more than I just showed here. Thank you for watching until the end. As further improvement, we could consider adding a color palette to distinguish the lines even more, or incorporating several such effects simultaneously, which would interweave and create interesting patterns. Anyway, I hope you enjoyed the video and wish you good luck with your projects. See you in the next video.